Okay, so if I want to graph y equals sine of x, and on the practice test and on the test, I will have everything marked out for you. I will have the axes all marked out for you, so you don't even have to worry about that. Everything's going to be set up for you, ready to go. I make it very straightforward on what you need to do. Okay, what's a sine of x going to look like for this crazy function? Sine of x. Where do we start? 0, 1, 0, -1, 0. If you get the dots in the right place, the only way you're going to miss points is if you go like this. I'm going to take off points for that, because they're V's. It should be a curve. You get to use the unit circle on your test, yes. Okay? Should be a curve, like that. Understand? Not V's, curves. Okay? On the same axis, you don't have to do, you won't be this way on the test, but I'm just going to save time. Y equals cosine of x. Where do we start cosine? 1, 0. And, okay, this is where you lose points on this one. Going like that. Because you know what that makes it look like? It makes it look like it goes like that. And I've even had some people in the test go like that before. Oh, if you do that, oh, no. That'll lose you points. Curvy, like it looks like it's going to go back down again. Like that. Okay? You might think, well, that doesn't make much of a difference. It does in my mind. And if it makes a difference in my mind and I'm the one grading it, please do it the right way. What? Y equals cosecant of x. Okay, cosecant is the reciprocal of what? Sine. Good job, Nathan. You are on the ball today. But most days you're on the ball. Most days. All right. So, the sine curve, and I want the sine curve graphed when you do this. 0, 1, 0, -1, 0. Okay? Then, you're going to put asymptotes where the curve hits the x-axis. And then the cosecant is a parabola. Again, this is what's going to cost you points on the test. I've seen this done before. That doesn't cut it. No, not at all. You got to get over by your asymptotes. As long as you're over by your asymptotes, you're good. This is, that's not looking too good. I'd never take off the point for that. Never. Because that should be maybe a little arc more down like that, but I'm not going to do that. But if you go, yeah, I am going to take off points for that. Okay? And people do that. Trust me. Every year it seems like people do that. And it's like, people, no. Not curves. Well, these are curves. So, y equals secant of x. Okay, now, Mr. Bierschbach is going to warn you today to please do it Mr. Bierschbach's way. And then you'll forget on Monday. You'll beg for forgiveness. And if I'm in a good mood, which usually I am, because I love you guys are wonderful, I'll probably give you the benefit of the doubt. But what does the cosine curve look like? 1, 0, -1, 0, 1. That is not a V. Okay, now on this, our asymptotes are here and here. So if you stop right there, I don't like that. So this cosine curve still continues on to here, right? I want another one over here. Or over here. Okay? So then when you're doing your secant curve, it's going to be like this and like this. Now I've had people go like this before. I don't count off for that. But I want two full parabolas, whether it's here and here or whether it's here and here with an asymptote drawn over here. I want two full parabolas. Got it? You've been duly warned. Okay? Y equals tangent of x. All right. So when we do tangent of x, you got to know where your asymptotes go. Okay? Now, someone just asked, can we use our unit circle on this? Absolutely, because that'll help you know where your asymptotes go for tangent. So where are your asymptotes for tangent? Are they at 0, pi, and 2 pi? Or pi over 2, 3 pi over 2, 5 pi over 2 for tangent? Well, at 0, if you look at 0, is y over x, sine over cosine, equal to 0 or 1? Is y over x equal to 0 or 1 at 0? It's equal to 0. So does that mean there's an asymptote there? No, it's where it's 1 over 0. So where are we have a y value of 1 and an x value of 0? At pi over 2. So you're going to have an asymptote at pi over 2, 3 pi over 2, and then at 5 pi over 2. Okay? Now, halfway in between your asymptotes, where is there going to be a point? 0. Halfway in between your asymptotes is going to be a point at 0. Halfway in between that point and the asymptote is tangent a positive slope or a negative slope? Positive slope. Tangent is positive. So halfway in between here and here, we must be going up if it's a positive slope. So if this is 1 and this is 2, -1, -2, we're here, so we have along the asymptote, slide over along the asymptote. Along the asymptote, slide over along the asymptote. Good? Okay, go tangent. Don't hurt yourself. Okay, cotangent, where's our asymptotes going to be at? No. Cotangent, 0, pi, and 2 pi for cotangent. Because cotangent is cosine over sine, so it's x over y. So where the x over the y is equal to 1 over 0, which is 0, pi, 2 pi. See, all right, so is cotangent a positive or negative slope? Negative. Oh, and this is where people have done it wrong in the past. They go like this. What did I do wrong with that one? Not close enough to the asymptote to make Mr. Bierschbeck happy. So you gotta get close to the asymptote. Okay? Okay, now, the great thing about graphing these 6 problems first is on the next 3 problems, they're just offshoots of secant, cosecant, and cotangent and tangent. Okay? They're just offshoots of that. So then basically what you do is you look at these graphs and just slide them right, left, up, down, whatever you need to do. So let's say I have y equals cosecant of x plus 1. And then this is the one that tends to kill people on a yearly basis. It's a cosecant graph just done what to it? Moved up 1. Okay? This is where you're going to go wrong, and this is why I do this one today. So everybody sees what happens. So pi over 2, pi, 3 pi over 2, 2 pi. 1, 2, 3, -1, -2. Okay, so the cosecant curve comes from the sine curve or the cosine curve. So I want to see the sine curve graph. And then after that, we're going to move the sine curve where? Up 1. Okay, now, let's watch for a second. This is a cosecant of x, okay? All I'm doing is sliding everything up by 1. Do my asymptotes change where they go? Why would they change asymptotes? But here's a mistake people make. They say, well, we only touch the x-axis right here. So there's an asymptote there. And then I don't have an asymptote till way over here. Oh, no. No, don't make that mistake. Please don't make that mistake. That's not what we're trying to accomplish. We're trying to accomplish, do you know this just goes straight up? So your asymptote doesn't change position if you slide up or down. It stays in the same place. So your asymptotes are there. Your parabolas are here and here. Be careful not to go off of this one because you slid up. So it's off of this one. Okay. Can you handle that? Everything slid up 1, but I've had people put the asymptotes in the wrong place because they say, well, the asymptote was where we hit the x-axis. Well, that's on a normal curve. And then if you squeeze them down, yep, it's where you squeeze down. But if you're just shifting everything up, it's just a shift up. It shouldn't change that much. Okay? So let's say y equals secant of 2x. What happens here? It compresses it in the horizontal or vertical direction. Horizontally. Okay. So, secant is from what? Sine or cosine? So y equals cosine of x is where we derive it from. So 1, 2, -1, -2, pi over 4, pi, 3 pi. Oh, what am I? It's very back. Pi over 2, 2 pi. So cosine of x, 0. Okay. So if we're squeezing it twice as skinny, basically, before I draw my secant graph, I'm going to draw my cosine graph of 2x. So I'm making it twice as skinny. Here, 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 here. And because I'm not hitting the x-axis enough, I'm going to go to here as well. Okay? So then, where do my asymptotes go? Well, they go at pi over 4 right here, 3 pi over 4, 5 pi over 4. And then I make my parabola down and my parabola up. Okay? So you can handle that, right? What if we did like the tangent of x minus pi over 4? What are we doing there? Move the tangent curve to the right. So what I have people do is I say, just look at your tangent curve and then just move everything that many spaces to the right. So they go back, they look at their tangent curve. Where's our asymptotes at? Pi over 2 and 3 pi over 2, right? How far is, if I go 8 spaces to pi, which is how far I go on the test, I'm almost guaranteeing that. If I go 8 spaces to pi, how many squares is it going to be to get to pi over 4? 2. So everything that you see on the graph, the asymptotes, the curves, move 2 squares to the right. So when we graph this, I don't have you graph the original tangent curve. I just have you graph the final one when it's tangent and cotangent, because otherwise there's just too many lines involved. So pi over 2, pi, 3 pi over 2, 2 pi. So at pi over 4, there's an asymptote, right? Ooh, no, there's not, is there? Where's our asymptote? It would be 3 pi over 4, and then 3 pi over 2, this way. And then, how many squares did I go? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So, tangent, remember, halfway in between your asymptotes, you got 0, 1, negative 1. Okay? And then the last, so that's the problems 7, 8, 9 will look like those. Okay? And then your last problems, and I'm only going to do one of these, will be like this. 2 sine of 3 times x minus pi over 4. Let's go plus pi over 4 minus 1. I don't want a 3. Let's go with 2. There we go. Okay? You're going to look like that. So you're just going to, and everything's going to be all set up in a graph. You're just going to have to graph this 5 times. So that's why you have 5 colors with you. Okay? So 1, 2, 3, negative 1, negative 2, negative 3. Pi over 4, pi, 3 pi, Mr. Bierschbach, 3 pi over 2, 2 pi. Yeah, I don't know, something wrong with me today. Okay, so we're going to graph y equals sine of x first. I want to see each, on the last page, I want to see each of the separate graphs. Don't combine 2 at a time. So I'm going to graph the sine curve. Then I'm going to graph y equals 2 sine of x. Then I'm going to graph y equals 2 sine of 2x. What's that 2x going to do? Make it twice as skinny. Nathan stayed up way too late last night. He's fallen asleep 3 times already in class today. And then plus pi over 4 moves it where? Two spaces to the left.